Hey class, today we are going to be solving systems algebraically, which this lesson is found in section 3-2, part 1 of your textbook. Our objective is to solve linear systems using substitution. Okay, so in our first example, we are asked to find the solution of the system of equations. And specifically by substitution. So let me kind of go back. We've talked about substitution before. A lot of times when we are asked to evaluate, I ask you all in class to tell me, instead of plug in, I say, well, what's the mathematical term we use, which is substitution, which means we are substituting a number for a variable. And actually, now that we are moving on to this phase, we are going to be substituting expressions in for a variable. And remember, even at the most basic form, substitute just means to replace. So here we go. For substitution to take place, we have to decide what variable we want to solve for. Reason being, if we figure out what variable, for example, if we have like an, oops, didn't mean to move that. If we have like an x equals 5, well then I could take this 5 and substitute it into one of the equations, right? But that's not what we have. Right now we just have two equations. So what we're going to do is analyze or take a closer look at both equations and determine, is there a variable that we can easily solve for currently? And to determine what that is, you look for the single variable, meaning the variable with a 1 as the coefficient. So if I look at both equations, I notice that this y is single. So I'm going to solve for that y, meaning I'm going to isolate it. So to isolate it, I need to move the 2x over. How do I move it? I'm going to subtract it. So that will mean that y is equal to negative 2x, that's negative 2x plus 10. This will be the expression that we use to replace y in the next equation. So here we go. We will have 3x plus 4 in parentheses, negative 2x plus 10 equal to 12. And then we're just going to continue to solve. Notice here with the 4, we're actually going to distribute. So we will have 3x in the front, doesn't change. 4 times negative 2x is negative 8x. 4 times 10 is positive 40. And this will still all equal 12. At this point, we're trying to solve for x. So 3x minus 8x, we can simplify that to negative 5x. So negative 5x plus 40 equals 12. Again, if I continue to solve for x, I would need to move 40 over by subtracting it. So I have negative 5x equal to negative 28. And then if we continue, we will divide by negative 5. And no, it's not going to be pretty. But we will leave this as x equals 28 over 5. Alright, so now that we know exactly the number that x is, I can finally substitute that into our other equation, or our first equation that we decided to manipulate. So here we go. We would have y is equal to negative 2 times 28 over 5 plus 10. Order of operations would say to multiply first. So we would have y is equal to, if I multiply negative 2 and positive 28, I'd have negative 54, or excuse me, negative 56 over 5 plus 10. I'm really not liking these fractions, but we're going to keep going with the fractions. If I wanted a common denominator, I would need both to be over 5. Okay, both would have to have a denominator of 5. So let's go ahead and make this 10 a 50 over 5. So I'm going to rewrite this now as 50 over 5. How did I get that? I multiply both the numerator and the denominator by 5. So negative 56 and positive 50 will then give me a y value of negative 6 over 5. Remember, when we are writing a solution of a system, we will not leave it in this form because this x actually would represent a line and y would represent a line, but our solution is always an ordered pair. So our answer would be 28 over 5, comma, negative 6 over 5. And I believe if we wanted to change those to decimals, that would be 5.6, comma, negative 1.2. I would prefer leaving it in fraction form though. So there's our answer. Let's practice that again. Hopefully the next one we won't have fractions, but let's see. And try one again. When we're choosing substitution, we are choosing to solve for a single variable. So we analyze, we look at both equations, and we determine, hey, is there a single variable? And in this case, there's that x. So to get that x by itself, we need to isolate it by moving everything away from it. So I need to move the 3y by subtracting 3y on both sides. So x will equal negative 3y plus 15. Or you can say 15 minus 3y is the same thing, but this is what we're substituting into the next equation. So let's start substituting. So I would have negative 2. My x is now negative 3y plus 15. If I finish that expression, it's minus 4y equals negative 5. This negative 2 needs to be distributed, so I would have positive 6y minus 30 minus 4y equals negative 5. If I continue to simplify, 6y and negative 4y will make 2y minus 30 equals negative 5. Again, I'm solving for y, so I need to add 30 by moving it over. So I would have 2y equal to, oops, sorry, that's positive. So that would be equal to 25, and oh, looks like we'll still have a fraction anyway. So y will equal 25 over 2. And actually, this one is one that's pretty easy to switch over if we wanted to do decimal form. So let's go ahead and switch it over. 25 over 2, that same thing as saying 25 divided by 2, which means that y is 12.5. So at least now we know our y value. So we will substitute that value into our manipulated first equation. So here we go. We would have x is equal to negative 3 times 12.5 plus 15. So that would mean that x is equal to, and I got to get out my calculator, so give me a second. That would be 12.5 times negative 3, which is negative 37.5 plus 15. So our x value would be 22.5. And again, leaving it as just an x and a y is not acceptable. So we will write our final answer, a solution, as an ordered pair, which is 22.5, comma, 12.5. This is our final answer. So if I were to have graphed both of those equations, my point of intersection would be 22.5, comma, 12.5. All right, in example 2, we are using substitution to now solve a problem. So you'll notice this is a word problem, so we are going to have to rewrite or get our word problem we would have to create our equation from the word problem. So we need to look for our key information and then create our equation from that. So it says a music store offers piano lessons at a discount for customers buying new pianos. The cost for 6 lessons is $300 and the cost for 12 lessons is $480. Each price includes the same one-time materials fee. What is the cost of each lesson and the one-time fee for the materials? So normally when you're trying to determine what variables and what numbers should be associated with your variables, it's in the question. And our question asks about lessons and a one-time fee. So if we look at our first sentence that deals with numbers, they're telling us that our lessons is 6, and then the final value is 300. What we paid is 300. In the second equation, we're told that there are 12 lessons, but we've paid 480. However, they tell us that for both equations, they use the same one-time materials fee. What's so great about knowing that they're the same is since they're the same, we don't actually need to know what they are. They can just be some value of y. So when we write our equations, it will deal with lessons plus the fee will equal the cost. So again, lessons plus the fee will equal the cost. Okay, so let's take a look on the next screen what those equations will be. All right, so if we write our equations on this slide from the previous slide, we will know that 6 lessons plus the one-time fee will equal $300. It's supposed to be 300. Okay, that looks really bad. 300. And then we also know that 12 lessons plus the same one-time fee will equal $480. And again, I told you to analyze both equations and determine determine if you find a single variable. And in both, we do find a single variable. We find an f. So since we're solving, we could solve in either equation for f. I would rather deal with the smaller numbers. So to solve for f in this one, I would subtract 6L, meaning I want to move 6L on both sides. And I would get that f is equal to negative 6L plus 300. All right, so now this is what we're going to use to substitute for f in the second equation. So 12L plus, in parentheses, you should always substitute using parentheses, negative 6L plus 300 equal to 480. The reason why we want to use parentheses is, for example, if that didn't say 12L plus, but instead 12L minus, we would then have had to distribute the negative to everything inside the parentheses, which makes a big difference in your problem. So be sure that you always use parentheses when substituting. All right, so moving on, we have, since in this case we're adding, we really don't actually need to pay attention to the parentheses. So I could just simplify 12L and negative 6L to positive 6L. So 6L plus 300 equals 480. If I subtract 300, I have that 6L equals 180. And if I divide by 6, then I find out that every lesson is $30. So $30 per lesson. And again, if you use the context of the problem, we don't then have to determine, for example, what X and Y are. We can just use whatever variable we're using. So again, now that I know that there are $30 per lesson, now I can figure out how much the fee is. So the fee is negative 6 times the amount of the lesson. So the lesson was $30 plus 300. So the fee is negative 180 plus 300, which means that the fee is $120, and that's 300. $120 as the one-time fee. So now we've answered the question in the context of the problem. All right, in try 2, we have another word problem, so let's practice. It says an online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. What is the cost of each download and registration fee? So again, we're talking about the overall cost with each download and then the registration fee. Again, they're telling us that the registration fee is the same Okay, so dealing with the context, we know that for 15 downloads, the cost is $19.75, and for 40 downloads, the cost is $43.50. So let's go ahead and write up those equations and solve on the next screen. So our first equation would be, if I'm talking about 15 downloads, so 15 downloads plus the one-time fee costs $19.75. In the second equation, I have 40 downloads plus the one-time fee equals $43.50. And we're just trying to figure out how much it costs for downloads and the fee. Well, again, the fee is the same, so let's, and it's the single variable, so let's deal with solving for f where there are smaller numbers. So we will solve for this f. To solve for that f, we need to get f by itself by subtracting 15d on both sides. So that means that f will equal negative 15d plus 1975. All right, that's our fee. We're going to substitute it into the next equation. So here we go. We will have that 40d plus, in parentheses, negative 15d plus 1975 is equal to $43.50. So again, we can ignore the parentheses here because we're not distributing a negative inside. So if I simplify 40d and negative 15d, I would get 25d plus 1975 equal to $43.50. Again, I need to get d by itself, so I need to subtract 1975 on both sides. So 25d will equal, let's see, $43.50 minus 1975 is $23.75. If I divide by 25 then, I would get that each download is 95 cents, so 0.95 per download, which that's a dollar sign. Okay, so again, with that information, I would then substitute 95 cents into our first equation to find out what the fee is. So F will equal negative 15 times our download price, which is 95 cents, plus 1975. So 15 times our 95 cents will equal negative $14.25 plus the 1975. So our fee will equal $5.50. So $5.50 one-time fee. And now we've solved the problem in the context of this problem. Again, guys, here's your homework. There's an error on the page, I realize. The first homework should be for pre-AP. The second one is for algebra. Okay, remember, if you have any questions, come see me in the morning for tutoring.